All right, hello and welcome. Today, we're going to try and completely change the way you see long division. Seriously, I want you to just forget that boring, repetitive thing you might remember from school. We're going to pull back the curtain and see it for what it really is, this fascinating story, a whole narrative about place value, paying attention, and finding meaning. Okay, so to kick things off, let's start with this little poem. It perfectly sets the stage. It captures that classic showdown, the super fast calculator versus the, well, stubborn step-by-step march of long division. But that last line, that's the whole point of what we're talking about today. Yeah, a calculator gets the answer in a blink, but long division teaches us how to think. So how does it do that? How on earth does long division teach us to think? Well, the secret is all in how you frame it. We've got to stop looking at it as just some boring calculation. Instead, we need to start seeing it as a story. And you know what the main plot of that story is? The remainders. And I just love this idea. Think about it. The answer you get at the end, the quotient, that's just the headline. It gives you the big news, sure, but that's it. The real story, with all the drama and the plot twists, well, that unfolds in the sequence of remainders you find along the way. This is exactly why it's so powerful to think of long division as, get this, a literacy event. I mean, it's not just crunching numbers, right? You're actually reading a diagram that's laid out in this weird, nonlinear way. You have to track the plot, that whole divide, multiply, subtract cycle. And most importantly, you have to be able to narrate your decisions, to actually explain why you're doing what you're doing at each step. So let's give the remainder the respect it truly deserves, okay? It is not just a leftover. No way. Each remainder is like a little witness that pops up in the story to certify what's still unresolved. It's basically telling you, hey, hold on, we're not done yet. We still have to deal with this much before we can continue. It's literally the heartbeat of the whole process. And this whole idea, it's so powerful that it actually explains a fundamental rule about decimals. I mean, have you ever really stopped to wonder why a decimal either has to end, like 0.25, or it has to repeat forever, like 0.333? It's all because of the remainder story. Think about it. If you're dividing by, say, the number 7, there's only a limited number of possible remainders you can get. So if your remainder eventually hits 0, the story's over, the decimal terminates. But if it never hits 0, you are guaranteed to eventually repeat a remainder you've already seen. And the moment that happens, the whole story and all the digits in your answer start repeating in a perfect loop. It's so elegant. Okay, let's actually see this in action. We're going to look at a tale of two different fractions. First up, a story with a nice, clean ending. And then we'll check out a story that goes on forever in this really beautiful, predictable pattern. So we're going to start with 1 divided by 8. This is our story with a clear, satisfying ending. No cliffhangers on this one, I promise. All right, here it is, the standard algorithm. This probably looks pretty familiar to most of you from school, right? You can see all the classic steps: divide, multiply, subtract, bring down. It's a very neat, very orderly process that gets us to our headline answer, 0.125. But now, let's peek behind the curtain at the real story. We're not looking at the quotient digits, we're looking at the remainders. See how it goes? The first remainder is 1, the next one is 2, then we get a 4, and finally, there it is, a remainder of 0. That 0 is the final word. It's the end of our story. It tells us the division is complete. Okay, let's switch gears completely, now for a story with a really cool plot twist. This one never actually ends. Instead, it just repeats itself forever in this beautiful, elegant loop. This is the story of 1 divided by 7. And just by looking at the standard calculation here for 1/7, you can tell something totally different is happening. You see that long string of digits, 1, 4, 2, 8, 5, 7, and that little bar over the top? That's our clue that this exact sequence is going to repeat forever. But why does it do that? Well, the answer, of course, is in the remainder story, and this is so cool. Let's follow it. After the first step, our remainder is a 3, then a 2, then a 6, then 4, then 5, and then, look at that, we get a remainder of 1 again. That's the exact same remainder we started with. The second we see that number pop up again, we know the story is about to repeat. It's a signal that the whole plot is going to start over, and it will generate that same string of digits forever. You see, understanding this hidden story, That's what gives long division its real power. Its beauty. It's not just about getting an answer. It's about understanding a deep and elegant process. And, this brings us to a really important question. I mean, let's be real. In an age of calculators and AI, why should anyone, especially a student, bother with this? It can feel tedious, right? Especially when your phone can give you the answer in like a tenth of a second. It's a totally fair question. And here's the answer. It was never a race against the calculator. The goal isn't speed, it's about what you learn along the way. Practicing long division is like taking your brain to the gym. It builds up your mental muscles for things like estimation, for checking if an answer even makes sense. It forces you to pay super close attention to place value. You learn to spot your own errors by watching the remainders. And that logical loop, that check something, do something, repeat process, that is a fundamental skill that you'll use in algebra and even when you're tracing code. So if we're going to teach this effectively, we have to be smart about it. From a learning science point of view, it's all about managing something called cognitive load, which is just a fancy way of saying how much mental energy a student is using. We need to cut down on all the confusing, distracting stuff, the extraneous load, like messy handwriting or losing your place. We want to free up their brain's bandwidth so they can focus on what's really important, the germane load, the part where they're actually making sense of the story. So how do we do that? Well, we can use some really simple, clever design moves to make the whole thing more readable. Things like using grid paper to keep everything lined up perfectly, or building in little pause points to ask, okay, what does this remainder tell us? We can even use sentence frames to help students talk through the steps out loud before they write anything down. See, these aren't complicated tricks. They're just simple ways to clear away the clutter so the story can shine through. When we focus on the story and when we make that story easy to see and easy to talk about, we're really empowering students. We're not just handing them a procedure to memorize, we're giving them a narrative that they can read, that they can say out loud, and that they can actually own for themselves. When you get right down to it, long division is a really human algorithm. It's not fast like a computer, no, but it's careful. It's talkative, and you can check your work every step of the way. Its real beauty isn't in the quotient at the end, but in the meaning you find in every single step. So let's share that story with students. Let's let them read it, say it, and own it. And let's help them see that the most important lesson is that a remainder is never just a scrap. It's always the start of the next chapter.